So how about this first one? It's pretty easy. Which one is that? Yep, that's side, side, side. So yes. All right, what is the green X in the middle? Does that mean don't look at this line? Does it mean like these are no good? What's that telling us? They're congruent. Well, it is congruent. Yeah, to what? Yeah, to itself. And what is that property called? Starts with an R. Yeah, that's the reflexive property. How many of you looked in the mirror this morning? Let me take that out. Okay, I kind of think of this one as like the reflective property, like a mirror. Like it's, if you look in the mirror, you know that image is congruent to you. It's not reflective, but it's kind of close. Anyway, which property or which theorem are we going to use to prove that these are congruent? This is SAS, good. Okay, this one does not have the middle line marked, but we know that it's part of both triangles, so we could mark that. And that's, again, the reflexive property. So there's actually more than one way to prove these triangles are congruent. So give me a couple of them. Angle, side angle. Let me just mark what that is. So angle, and then side there, the reflexive side, and then the other angle. So angle, side angle works. Okay, what else? Okay, so S, side, and then angle, and then sweep around to the other side. So side angle, side works. Okay, what else? There's one more. And it might even help if I remove that for a second. Yeah. So if we do angle and then skip all the way to this angle and then around to that side. So angle, angle, side, or side, angle, angle. And honestly, a lot of proofs have more than one way that you can work through them, which is nice to have options. Okay. How about this one? Yeah, that's angle, side, angle. And the last one? Side, side, side. Good. And again, that line is part of both triangles, so that's the reflexive property. How'd you do on that, Did it go okay? Okay. All right, let's look at your homework. And there are a couple of these that just wanted to talk through. And we'll start with number 6. As the picture is given, you only have 2 angles. So angle and angle, which is not enough to prove some congruence. So what do we have to add to that? Yeah, you got to go in here and add that line down the middle, the one that's shared by both triangles, that's reflexive congruence. And so we have angle, angle, side on that. And look at number 8. Which one is that? Well, we have side and side, but the angle in between is not marked as congruent. So if we went around the figure, we don't know anything about that top angle. So not side angle side. Good try though. Yeah, this is actually HL. This is one that I don't think we've said. We've noted that it works, but haven't seen it. So how do we know? Well, first of all, you note that these are right triangles. It has to be that first. And then KL is a hypotenuse, so is MN. And then one of the other sides, those are called legs. So that's actually HL. Okay, on this one, number, whatever that number is, must be 7. Oh yeah, it's locked in there with the figure. you're marked side, 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 but what else could you do? Like, what other way could you prove this? Yeah, because we know these are vertical angles, and so we could do side, angle, side as well as side, side, side. You don't have to do both. It's just good to see that you have options. What else? There seemed like there was another one I wanted to mention. Yeah, 15 is a little bit suspicious. Sus. Why? Why is it? Does it look like it's congruent? Is it? No, and why not? Yeah, like we have all these markings showing like the stuff's congruent, but they're not congruent to each other. So we have one arc mark and two arc marks. So not congruent. All right, any others that you had trouble with? Okay, let me show you the answers to the rest of them. And here they are. Number 1 was no. In that case, we just didn't have enough information. We only had angle, angle, and that wasn't enough. Number 2, yes. Good morning. And on that one, I marked it as angle, angle, side.
I have little kids that still need take panorama. So I don't know if you want to do it later. Or,
Who is it?
I can call their names out if you want.
Oh, yeah, do that.
Yeah, if I call your name, you need to take panorama. So when you have time in this class period, you can take it. Just a quick thing, too. The middle response on panorama counts as negative, not neutral. So if you want to be negative, by all means, you can still be negative. But if you want to be positive, be positive. Just know the middle response it counts as a negative response because you have 5 choices. So Shayla Baldwin, James Diamante, Alexis Guzman, Raylan Hernandez, Aiden Hubbard, Peyton Lively. Nathan.
Number 2, AAS. Where'd the side come from? Yeah, that was the reflexive property line GJ in the middle. Okay, number 3, SSA. Number 4, SSA. So both of those are no. Remember, SSA or ASS, that doesn't work. Number 5, angle, side, angle. Number 6, angle, angle, side. Again, that reflexive line AD down the middle. Number 7, we talked about. 8, same thing. Number 9 is SAS. Side, angle, side, reflexive property down the middle. Number 10, angle, angle, angle is not okay. That's one of the no-no ones, so it is not congruent. Even though those look really good. Number 11, side, angle, side. Number 12, angle, side, angle. Where'd the other angle come from on number 12? Yep, the vertical there at J. 13 is another hypotenuse leg. 14 is side, side, side. And then 15, we said no. All right. So Friday, we have that quiz coming. I can't zoom it out, but this kind of stuff will be part of the quiz. So think 4 or 5, maybe 6 of these, where you're just given an image, well, 2 triangles in some form or fashion. You might have to know that the middle line is reflexive congruent, or maybe that you have to add in another angle using vertical angles or something. Okay? So give me a fist to 5 on that at this point. Fist to 5. Okay. And just before I send you off to start reviewing, I'll tell you about that too in a second, but something we haven't done just in a couple days. So on a sheet of paper, I want you to simplify each of these radicals. That will be on there. So we'll take 5 minutes on this just to review simplifying radicals. Okay, remember our job here is to, when it says simplify, we're not just square rooting on the calculator, but we want to split these up into two square roots that are multiplied together. The first one needs to be neatly square rootable. The second one we don't really worry about. So the neatly square rootable ones called perfect squares are 4, 9, 16, what's the rest? Yeah, 25, 36, 49, 64, 81. Yeah, and we could keep going, but usually this is sufficient. So what goes into 40 on that list? Yeah, so 4 times 10. And then the square root of 4 is just 2. Is there another one of those numbers, one of these perfect square factors, in 10? Nope. So this is the end. 2 root 10. Okay, 200. What goes into that? Yeah, we want the biggest number. Like 4 goes into it, and that's fine. 25 goes into it. You could use 25 as well. Just know that if you do it that way, you'll have to do this process more than once. I'll show you what I mean. Okay, if we did square root of 25 times square root of 8, that's fine. But then we need, so that would be square root of 25 is 5. Square root of 8 is going to get split up into square root of 4 times square root of 2. And then we get 5 times 2 square root of 2, which equals 10 root 2. So you could do it with 25. You could do it with 4 and have to do it like 3 or 4 times. What Parker said was, what if we just did a square root of 100 times square root of 2? Well, square root of 100 is 10. So 10 root 2. It's just a little faster. But either way is fine. How about 90? What goes into 90 on the list? Does 4 go into 90? 4 doesn't go into 90. Does 9? Yeah, 9 does. Okay, so square root of 9 times square root of 10. And square root of 9 becomes 3. Square root of 10, you can't simplify. So remember, this isn't about being an even number, dividing by 2 or anything like that. It's whether or not it's square rootable. Square rootable neatly. All right, square root of 81 is what? Just 9. That one was, there's no leftover square root. It's just a perfect square. All right, 550. Does 4 go into 550? Nope. Does 9? No. How about 16? Could. I doubt it. 25? 25 does. Okay. How many times does 25 go into 550? Wait, what did you say? Yeah. Okay, square root of 25 is 5. Does the square root of 22 have any of these factors in it? Like, in other words, can we split that anymore? No. Okay, how'd that go? So you'll need to be able to do that on there, on the quiz. Couple other reminders. And then I'll talk to you about those papers. So keep in mind, maybe it's something like this. Okay, and it says solve for x. What do you do? Okay, And before we do that, do these three side lengths add up to 180? No, because they're not angles, right? So they have nothing to do with 180. So why do we need this angle in the bottom left corner? Yeah, Isaac? Yeah. We need to know what kind of triangle this is. So if you add 50 plus 65, you get 115. And then subtract, you get 65. What kind of triangle is it? Yeah, now we know it's isosceles. So we know these two sides are congruent. So how do we solve for x? Yeah, just those two sides. Set those two equal to each other and then solve. Okay, so that one is not entirely obvious. When you look at it, you're kind of like, how do I solve for x? So keep in mind those isosceles relationships, the equilateral relationships. What if we have something like this? Okay, and I say like, this is 60, no, this is 70, and this is x. Does that work? Maybe I'll put one more piece on here. Let's say this is 40. There we go. And how do you solve for x in that case? So again, using these relationships that we learned, what would you do? How come? Equilateral triangle. All what degree angles? Yeah, so we can mark 60s in all of these. Okay, now what? How are we going to get into the triangle with x? Okay, why 180? These three angles add to 180. They're not a linear pair, but they're called what? What's that S word? Supplementary, yeah, good. Okay, so 60 plus 40 plus some question mark angle is 180. So what is the question mark? 80. Okay, what is x then?
30.
Yep. Now, what did I screw up on that? I wanted you to think through that process, but in haste, I just made up something, and what's wrong with it? Yeah, based on the notation, x should be 70, right? And so we could have just said, hey, x is 70 right away. When I stuck the 40 on there, that's what messed it up. So good job for finding that error. But that kind of thinking process, obviously I won't make one up that quick on the test. That kind of thinking process will be something you need to do. Okay. Also, we talked about the triangle inequalities theorem. So we've reviewed that pretty consistently since we learned it, but just to remind you what that looks like. Something like this. And if it says solve for x, what would you do? Okay, and so it's going to say the directions on these kind will say something like find a range of values of x or something, which kind of, that should indicate to you that we're talking about the triangle inequalities theorem and not just some solving. Okay, what are the other two? Amaya, give us another one.
2x plus 1 or 7x plus 1.
Good. Okay. How about Nathan? Can you give us the last one? How about you, Mason? Okay. Can you look at this and see which one is going to be the nonsense? Like do a quick solve in your head. I'm hoping it's not two different ones. Good morning. Yeah, it is going to be two. Okay. All right, good. What else is on there? I'll let you work for a bit, and if I think of something, I'll bring it back. So let me tell you about these 3 sheets that I just handed you. We haven't done actual proofs yet. So like, everybody grab this sheet. If you look at the back of that one, the last 2 problems are guided proofs. I'd like you to think through them, but that's not going to be on this quiz. You're not going to have to do a proof, okay? Otherwise, the rest of it is really good review for the quiz. Okay. And then everybody grab this one. The whole back page of this one is proofs. So again, you can think through them just to practice, but you don't have any proofs on the quiz. So the front side of that sheet is good review. Okay, and then you have the one that says lesson quiz. This is actually a quiz I've given in the past, but we're going to use it as review because the quiz I'm giving you is a little different. So all of the problems on there are good review. So we have, what, like an hour, I guess? No. What time do we get out? 25? Okay, so 45 minutes or so. I'll get you these papers. You have these 3 that you can work on. You have the isosceles and equilateral practice that I would review. You have the one that has this kind of stuff, as well as the simplifying radicals you can review. And of course your panorama. So if Mr. Hayward said your name, I do want you to do that before you leave class. It's really important for our school. The district is monitoring numbers super closely, and it's kind of an issue. So please get on and do those 2 surveys sometime between now and then. And if I think of anything else I want to remind you of, I will do that. Actually, I did think of one thing. I'll put it up here. And if you're taking notes, this like writing these down to review, that would be a good idea. So I'm going to tell you this statement. And these kind of problems come in various forms, like different pictures, different givens, that kind of thing. Okay, and if it says solve for x, what would you do? Sorry. So there is problems like this on this sheet, the one that says congruent triangles sheet. It's down at the bottom on the front page, so 8, 9, 10, that kind of stuff. Okay, what were you going to say?
I was going to say, same thing with A.
Side length. Okay. Here's what they're saying, in case you didn't follow. They're saying these two are congruent. Why? Yeah, those two triangles are congruent, which means, remember we wrote in the notes, that means they are identical. They are the exact same triangle. So we know that AB goes with DE. And remember I told you can read it in the name. The letters go in the same order. So the first two letters match the first two letters in case the triangles happen to be spun around weirdly. So even though we have lots of X's floating around, we only set those two equal to each other because they are congruent. And then we can just solve for X, and we'll get 7X and 3. Having trouble writing. There we go. Okay. So this is, we're going to go into proofs of this, but on that pink or orange sheet that you got, remember down at the bottom it said CPCTC? That says if two triangles are congruent, then all of their corresponding parts are congruent because they're identical. It's like if two people had the same iPhone and you're like, hey, look at my power button. Oh, look at my power button. It's the exact same. That's the same idea, right? Identical figures have identical parts. So just set them equal. All right, that's all I wanted to say for now. If I think of something else, I'll remind you, but just take some time to work